This is Dr. Gulshan S, your Physics Tutor. Today I'm going to talk about can resistance values be determined from color codes? Are these values exact? It's the answer to this question. And the next part is, what is a voltmeter? How should it be connected in circuit and why? What is an ammeter and how should it be connected in circuit and why? How does a potentiometer work and what may be the advantages of using a potentiometer instead of normal resistance? So let's first of all talk about the color code of resistances. So as you know that especially in the carbon resistances, the value of the resistance is coded as is expressed in the form of lines on the resistance itself. So the color code is, if you read these colors on the left column, black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, and silver. So there are three lines which read the value of the resistance from here to here, the lines which are starting from the left and they are closely packed. And there's one line or there may be no line on the right side. So first three lines correspond to the resistance value. So if you look at the values, then the first column will give you the value of the first line. So if it's black, it's 0. If it's brown, it's 1. And red is 2, and so on. And white is 9. So if I have a line like blue, so if the first line is blue, that means the color code for this is 6. Then the second line is also the value. And let's say the second line is orange. So after blue, suppose orange. Then orange corresponds to 3. And then the third line corresponds to the multiplier. So if the third line is say green, so the multiplier is 10 to the power 5. So the resistance of this would be 63 10 to the power 5 ohm or 6.3 mega ohm or 6.3 10 to the power 6 ohms. Okay, so this is the multiplier which is used to find the exact value of the resistance. So these resistances are coded in the form of colors. So first two band colors corresponding to the first two digits and third band corresponding to the multiplier. And then we talk of the tolerance. If we talk of the tolerance, then we look at this line, which is on the right side of the resistance. If the packed lines and the line which are having a separation and there is a single line on the right side. If there is no line, that means this resistance has 20% tolerance. So when we say 20% tolerance, it's not that it's a better resistance. This resistance can have a value which is plus minus 20% of the value which you already found by the color coding. And if it is a gold line here or golden line here, that means it has got a tolerance of 5%. So 5% tolerance if the gold line, no line means 20%. And if the silver line, then the tolerance of this resistance is 10%. So 5% resistance is a better resistance than 10 ohm resistance, 10 ohm tolerance, 10% tolerance resistance, and then 20% tolerance is a resistance which is quite inaccurate resistance. So generally, the resistance with 5% is preferred over a resistance with no band. That means gold band is preferred over no band. So, and then there's a few more nomenclatures which are used for finding the values of tolerance of these resistances. So this is about the color coding of the resistances. And then if I go to the second part of the question, that is what is a voltmeter? A voltmeter, as its name suggests, is a device used for measuring the potential difference or the voltage. So if you look at the voltmeter, it is, suppose this is your voltmeter. It has the polarity written on it. And there are two types of voltmeters, AC voltmeter and DC voltmeter. So here we are talking about the DC voltmeter. So voltmeter measures the potential difference and is always connected across the resistance or the component whose voltage you want to find. So a voltmeter is connected in parallel to the device whose potential difference is to be found. And this is a high resistance device. So a voltmeter is a device which is connected across. Suppose I want to find the voltage of this resistance, I'll put it across here. And if I want to find the voltage of this battery, I'll put it here. So a voltmeter is connected across a component whose potential difference you want to find out. Now let's talk about the ammeter. Ammeter measures current, and this is a device which is denoted by A. And if I want to calculate the current in this circuit, so what I'll have to do is I'll to break open this circuit and put an ammeter here in series. So here I'll connect an ammeter, and that ammeter will give me the value of current in the circuit. And remember, ammeter is a low resistance device. Why low resistance? Because it will not change the value of the current flowing the circuit. So its value is so small that whatever current is before its connection is almost the same even when it is connected to the circuit. Now let's talk about the potentiometer. Potentiometer plays a similar role as that to voltmeter, but there is a difference between voltmeter and potentiometer, that a voltmeter can be, say, 0 to 3 volts with an accuracy of, say, 0.1 volt. But if you want to measure a really very low voltage, say about 1.007 volts, then a voltmeter may not be as good as a potentiometer is. So a potentiometer is a long wire which is connected to a battery, which drops a potential across this, and that potential is dropped across that length of the wire, and therefore a term which is called potential gradient, that is dV by dR, determines the least count of this potentiometer. So suppose there is 2 volts dropped across a length of, say, 10 meters, and 10 meters changed to centimeters, 10. This will be volt per centimeter, will be the least count of this potentiometer, or the least voltage you can measure. And if it is, if you can measure up to millimeters, so it will be 2 divided by 10,000 volt per millimeter with the least count of this. And then the device or the voltage which you want to measure is connected here, and then a galvanometer, and then you slide this jockey on the slider and then balance it so that the galvanometer gives no deflection. At that position, the drop from here to here across that wire will correspond to the voltage of that device. And that length multiplied by the gradient will give you the voltage of that device. So this is more accurate, and it doesn't change the voltage which we want to measure. Whereas in the case of voltmeter, there is slight drop in the voltage before connecting and after connecting. After you connect a voltmeter, suppose the voltage was 3 volts, it may drop down to 2.9 volts. So voltmeter is not taken as accurate as the potentiometer is, but the potentiometer is not a portable device. It's a huge board with wires, 10, 12 wires mounted on a board, and then you need a battery main circuit which has to be stronger than the voltage which you want to measure, because this voltage across the wire is being balanced by the voltage which you want to measure. So it's more accurate, but then it's not portable, whereas voltmeter is slightly less accurate, but it's portable. You can carry it from one place to another. So these are the 3 answers to the question. We have talked about the resistances, color coding. We have talked about the voltmeter, which is connected across the device whose voltage you want to measure. Ammeter is to be connected in series with the circuit, and potentiometer is a device for measuring low voltages. And the low voltage is measured in terms of the potential gradient of the potentiometer, which is the voltage applied across the 2 ends divided by the length of the wire, and that becomes the least count of the potentiometer. Hope it should work. Thank you so much.